Yellow, jello. Hello, hello, hello. What's up? What's up? Eighth grade individuals. How are you all doing? Whether you're live or on demand with me here. Welcome to your last week of live streams. Right? Woohoo. Hope everybody's doing good. I hope we're having ourselves we had a good weekend, a good week. You said this is the last week of live streams here, so does it mean that we're gone and out of the way? No, we're here. So I mean, if you have any questions with anything, we're always here. So um, I'm always here. Obviously, reach out with any type of questions with email, all that kind of good stuff. I know they got some things set up here, so I hope everybody's doing good. So here's what's going to happen here. I'm going to cover topic 3 out of this, topic 3 out of the packet, topic 3. With the other two, live streams, I was able to get through. The idea is to go through topic 3 and 4. I was able to get through one topic in full, and then the other one will be for tomorrow. So that's the idea. I'm going to talk topic 3 in full. If you have any questions, please reach out. If you are, Stephen, yes, even Stephen, yes, even Stephen has his thing here. Try to see how long I can get like a blue thing. And see how long I can leave him right there. Oh my! Let's see how long I can leave him up here without having to delete even Stephen here. So here we go. I'm going to cover this in full. I'm going to talk a lot about this. Feel free to pause, rewind, and go back if I go too quickly through something, which is probably going to happen because there is a lot of information on this. But with that, with that being said, yes, even Stephen is especially when he has tape wrapped around him, right? So, um, so in this instance, we're talking about functions, relations and functions, relations and functions. Remember, a relation is a function. So remember a function. Remember a little function machine we had, the function machine, to where if each input or an x value has exactly one unique output or y value. Remember, if I drew a function, if I drew a function like you had right here, is this graph a function? Is this graph a function? Yes, it's a function. Each whatever x value that you have has exactly one y value. Okay, you don't have. If I were to draw something, and if I were to say, let's have, I'm going to draw this as my function. If I were to remember what I was saying in class, that vertical line test, and if that vertical line passes through 2 points on the function, then or on the graph, then it's not a function. Okay, that's what we're talking about here. So what's going to happen is I'm going to hit that trash button. I'm going to delete everything off the screen. This tape is his mom. Yes, tape. Let's see. Tape here. So number one is the relation shown in the table a function. Is the relation shown in the table a function? If I input a 2, if I input a 4, if I input a 6, if I input an 8, if I input a 10, if I'm inputting, that means think of it as the graph. If I was like 2, 4, 6, 8, and 10, and it has a 1, and then a 2, and then a 3, and then a 4, and then a 3. If I were to draw this, what's up, Brandon? What's up, Malachi? What's up, everybody? What's up? Okay, we're just talking topic 3. I'm going in full with this here. So, um, in this instance, if I were to draw that function like we had right here, if I were to draw this function, is this a function? Well, yes. Each individual input has exactly one output. 2 does not equal 1 and 2. Okay, it's each individual input has one output. Okay, that right there. So number 2 does the relation, and it shows you these pairs of numbers right here. Okay, let's look. If I had, it says, does it represent a function? It says, use the arrow diagram. Just for this instance, I'm going to be doing it down here because I can't write that small. So if I had, in this instance, let's use our x values. Let's have a -5. So -5, a 7. And it looks like we have a 3, and then we have another 3. That should kind of give you a little bit of a what's up, Brianna? So here's our input. Here's our input. If you go to our output over here, -5 to -3. You remember us drawing those arrow diagrams. 7 would go to 2. 3, the first 3 went to 8, but then you had another 3 going to -8. There's your problem. Your input, you have 3 equaling 2 different outputs. So the question is this a function? That is one big old no. No on that. It's no on this. Okay. No. Again, functions. Each individual input has exactly one output. Okay. I have it. I know I'm gonna get him in a second here. Okay. So let's scroll down here. So now we talk about representing the, actually like graphing and representing the function here. So we said Mark. So good old Mark. Mark has a gift card. Mark has a gift card to buy apps for his smartphone. Good for Mark. Good for Mark. He has $100 thing for his smartphone here. All right. That's I'm gonna have to do it. I'm gonna have to do it. Uh-oh. Oh no. So Mark has a $100 gift card to buy apps for his smartphone. Each week he buys one new app for $4.99. So it says write an equation that relates the amount left on the card Y over time. What does he start with? What does he start with? So here's my thing. I would do actually number 2 first before doing number 1. Because if I were to give you a $100 gift card at the start of everything here, at your 0 weeks, you're going to have $100 on that gift card, right? You're going to have $100 on that gift card. Every week, every week it goes down $4.99. So if I were to say at week one should be somewhat less than this. And it's hard for me to draw on this, but week 2 should be something less, 3 should be less, 4 should be less. Every week he's buying one new app. So the graph should look something like that. I mean, again, I'm on the computer, it's hard to do, but if you were to actually, show the distance, if I were to go down and over, it should be down 4.99 and then over 1. Or if you're looking at me, down 4.99 over 1 in that instance. It's talking about the slope as we're getting into that portion of things here. So the equation that relates the amount left on the card, okay, so the amount that is left on the card right there, well, y changes all the time on this. So if y changes, it's going to be, you're starting with that 100, right? So that 100, and you're subtracting 4.99 each week, right? 4.99x, 4.99x. It should look something along these lines right here. If you had it as y equaling -4.99x plus 100, that's the same thing. Okay, that's the same thing on that. Okay, but that's your equation for number 1. Trying to connect that each week. It's going down. It's a straight line. That function is a linear function. Linear line. Linear meaning line. So again, that's 100 minus 4.99x, and then the graph should look something like this. Something like that. We will continue. I don't know if I said it at the beginning, but this is the last week of live streams. So this is the last week of live streams. So, you know, hopefully everything is caught up. You guys are doing well. All that kind of good stuff. All right. So we talk about constant rate of changes and initial value, or your, or your like y-intercept. Remember me talking about that many times, tapping the board. So in this instance, function a. So if we looked at this, remember, y equals mx plus b. That's your equation for a line. So your initial value in this instance, your initial value for function a is going to be 2. Function b, if x equaled 1, and this is where, if you were to look at this, I had a graph. If I had a graph, I could say I'm going over 1, and then y is going to be down 1. If I'm over to 2 and it's up 1, I'm over to 3 and it's up to 3, I'm over to 4 and it's up to there. And if I connected these lines, where would our initial value be? Our initial value should be something like this right here. It's where it intercepts. So which one has a greater initial value? Well, it's going to be function A. It's going to be function A. Function A, because it's a 2. You have to draw that. You have to have that kind of mental idea of seeing the line go down and intercepting that y-intercept at a negative number. So now, which function has a greater rate of change? A greater rate of change or slope? So function A has a rate of change of -3. -3 right there, the one that's in front. Function B in this instance, remember our slope is change in y over change in x. So our change in y, if I'm taking 1 minus -1, I'm going to take these two right here. 1 minus -1 over 2 minus 1. 1 plus 1 is 2. 2 minus 1 is 1. That rate of change is 2 for function b, which has the greater rate of change. It's function b. Function b. Okay? Function b has a rate of change of 2. Okay? Hope this is coming across, guys. I know it's a lot of information, or kind of rehashing the memory there, but let's go down here. So if we talk about constructing functions now to model linear relationships, so it says, what's the equation of a line that passes through? And we kind of just did this here. We did this up top. So if I take these two data points right here, here's our y, those are our y. So if I take my change in y over my change in x, I can take my 18.5 minus 4.25, and I put this over 2 minus 0. So if I were to get my little fancy calculator right here, and if I were to take 18.5 and I subtract 4.25, it's going to give me 14.25. So if I get my 14.25 over 2, divide that by 2, it's going to give me 7.125, which it's 0.5. That's why. I was looking, I'm like, why is that not the case? 0.5. This is actually 1.5. There we go. So if I take my 14.25 and I divide by 1.5, it should give me 9.5. So my slope, my slope for that, my m is 9.5. That's a 9.5. Let's get all this off. Let's just do that. Slope slope is 9.5. All right. And it has a y-intercept of negative 0.5. That means my b is negative 0.5. So y equals mx plus b, right? If I take those values and substitute them in, y equals 9.5x plus negative 0.5 or minus 0.5, however you want to do it. There is your equation right there. Okay? Almost there, moving right along. So the graph shows the relationship of the number of gallons being drained from an aquarium over time. What function models that relationship? What function models that relationship? Now, this is where you have to sit there and take two data points, and this is hard on me drawing on a computer, but if I were to take two data points on the line, I know that if I start with y equaling mx plus b, my y-intercept here, my y-intercept is going to be 90. So I know that I'm going to have a 90 over there. Now I got to find what the slope is. The slope is going to be negative, but in this instance, if one of my points is at 90, so I know that it's going to be 90 divided by my change in x. So let's see. Off there for a second. Let's get this off real quick. So we know that my y-intercept is going to be 90. So I want to find 2 points on the line and find my change in the data points here. So my change in y, I'm going from 90 to 70. I'm going my 90 minus 70 divided by 2 minus 0. So it's going to be 20 over 2, which should give me 10. Which should give me a 10. And because it's going down, it's a negative 10. So y equals negative 10x. So y equals negative 10x plus 90. Okay? Y equals negative 10x plus 90. All right. That's 3, 4. Let's keep moving forward. Almost there. Number 5, this is actually really, really simple. Remember these intervals of increase and decrease. So it shows that graph, and you can think of it this way. The graph shows the altitude of an airplane over time. So think of this function. So think of that function in the intervals that are described. Well, in which intervals is the graph? Is the graph of the function constant? Constant, meaning flat. If you're in an airplane, which levels are going to be flat? If I'm going flat on an airplane, that will show you that it is not changing in height, right? So it's going to be 2, 4, and 6. Because remember, your slope is 0. A constant function is 0. Right? So number 2, in which intervals is the graph of the function decreasing? I hope you can see that the graph that function that is decreasing is what's going down. 7. So this should be 2, 4, and 6. And then this should be 7 as well as 5. Sorry, I didn't even see 5. So 2, 4, and 6, and then 5 and 7. Okay, 5 and 7. All right, 1 second. Almost there, got one more. So, talk about sketching functions. If you remember, we did this with our good Renaissance nonsense, all that good stuff. You can actually sketch the graph of a function to describe that behavior. So when sketching a function, you identify the variables such as input and output. We had to do, like in this instance, we were, the input of time. So as time goes on, as you'll see in our example, as time goes on, we talk about the number of carrots in the bowls over time. So the number of carrots in the bowl over time in this instance. So Jack's mother brings him a bowl of carrots as a snack. So when we have Jack's mother, Jack's mother brings Jack a bowl of carrots. Draw some carrots here. Woohoo. Bowl of carrots for good old Jack. Okay. So when she brings him that bowl of carrots, it doesn't matter how where you put the dot here, as long as you're showing that he has some form, that there are some amount of carrots that are in there. So you're starting with at some kind of a starting point. So at first, over time, he doesn't eat anything. It sits somewhere. Okay, it doesn't change. Okay, then he eats one at a time until half of the carrots are gone. So he eats one at a time until half of the carrots are gone. I have this distance between what would be 0 and what he has right here. Halfway would be right about there, right? So he eats one at a time. Number of carrots goes down until half are gone. Then he does not eat anymore. So he's left there. Now let me do this so I can kind of show it a little bit better. I'll actually break this down into. So at first, he does not eat any. So this first interval of time, Jack doesn't eat any. Okay. Then he eats one at a time until half of the carrots are gone. So then he eats one at a time until about half the carrots are gone. And then in our third interval here that it describes, then he does not eat anymore. So as you see, I have 3 different colors right there. 3 different colors. Then he does not eat anymore. That would be your graph that shows the number of carrots in the bowl over time. Again, that's a lot of information. I'm well aware of that. I hope, ladies and gentlemen, that everything right there at least has some facet of information right there, guys. So, hope it makes sense. If you guys have any questions, with anything on that, please, I can go more in depth if you need it for some reason. I can definitely go more in depth with everything. But with that being said, like, if you have any questions with anything, please reach out to me. Send me an email, Google Classroom, all that kind of good stuff. I'm here if you need it. Please reach out. I'm actually going to put my email into the chat again here. I would hope that you should know what my email is, but let me put this down here. .org. Okay. As this will take a second to come in. Come on now. There we go. Okay. So you should see my email there in the chat. If you have any questions with anything, please reach out. Guys, have a good day. I will go through topic 4 tomorrow and maybe other little things that I might want to pick up on. But with that being said, I hope you have a good day. Yeah, so have a good day. I'll talk to you.